Alright, we are section 6.2, properties of parallelograms. Let's look at the solve it. Use the information given in the diagram. Which triangles are congruent? How do you know? So we're really going to be looking into the properties as well as the definition of parallelogram. So, this theorem 6.3, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So, that means that if these two are parallel, given that these two are parallel because that's definition parallelogram, the property is that these two are congruent to each other and these two are congruent to each other. Let's see how we can. Alright, so problem 1. What is the measure of angle P in PQRS? So I took this picture out over here. Now PQRS is a parallelogram, that is given. So, if this is 64 degrees right here, I want to find angle P. Well, like we looked at before, the parallelogram, these two are parallel right here, and these two are parallel. Well, if these two lines are parallel, we can extend that. We can extend QP and SR. This is 64. These two are going to be same side interior right here. So because these are parallel and same side interior, these two are supplementary. So we're going to do 180 minus 64, which equals 116. That's what angle P equals. Also, because P and S are next to each other and they share a side, they're consecutive angles. So P and S, they're consecutive angles, they're next to each other, and also they are also same side interior if you took everything out. Alright, let us look at problem 2. Alright, you are given that parallelogram, that ABCD is a parallelogram. What you want to prove is angle A is congruent to angle C, and angle B is congruent to angle D. So, this is what we are given in this picture. Alright, so we always start with our given. Our given is that ABCD is a parallelogram. Okay, so now what we want to do next is we want to somehow get from here to somehow relating to the angles. So, let's look at the angles. Angle A and angle B and angle C and angle D. So, A and B and C and D. These are called consecutive angles. They are next to each other. So these are consecutive, and these are consecutive. That is definition of consecutive angles. Now, because they are consecutive, angles A and B and C and D, they are supplementary. These two are supplementary to each other, these two are supplementary to each other, and these two are supplementary to each other. Because consecutive angles are supplementary. So, because angle A and angle B and angle C are supplementary, that means angles A and C are supplementary to both. They are both supplementary to angle B. So therefore, you can state that angle A is congruent to angle C because they are supplements of the same angle. Supplements of the same angle are congruent. That is a theorem that I didn't get to go over in chapter 3. Alright, so same thing. Since angle B and angle C are supplementary, and angle C and angles D are supplementary, B and D are both supplementary to angle C. So therefore, we can say that angle B is congruent to angle D because supplements of the same angle are congruent. This is not substitution. This is a theorem. Supplements of the same angle are congruent. Right, and problem 3. Alright, so we want to solve for x and y. Now, there is a theorem 6.6, and I will write it right here. ABCD is a parallelogram. This is a parallelogram. So therefore, the diagonals bisect each other. Because these two are parallel, this pair is parallel to each other, these two are parallel to each other. When these diagonals are going to bisect each other. So therefore, these two segments are congruent to each other, and these two segments are congruent to each other. So if we turn over here to this parallelogram, I want to find x and y. So I know that x and y, so x equals y plus 2, and so these two are congruent to each other. I know these two are congruent to each other. So y plus 10 is going to equal 2x minus 10 because of the theorem here. So y plus 10 equals 2x, systems of equations here. But I know that x equals, so I'm going to plug in x into here. So I'm going to have y plus 10 equals 2 times the quantity of y plus 2 minus 10. Alright, so when I solve for that, when y plus 10 equals 2y plus 4 minus 10, then I'm going to subtract y on both sides, minus 6, so 16 equals y. So I solved that 16 equals y. Now I'm going to plug y back into here. So x equals 16 plus 2, which equals 18. So I solved it that I know these two are congruent to each other, so they equal each other. These two are congruent to each other because they equal each other. Alright, and the last problem, try to plot it down here. And also try to got it here, got it for number 1. Right, number 2, I got it right here. Alright, and number 4. Alright, in the figure, you are given that AE is parallel to BF, which is parallel to CG, which is parallel to DH. So you're given that all of these are parallel. If EF equals 2.25, then what's EH? So if you look at the theorem above right here, if 3 or more parallel lines cut off one congruent segment on one transversal, then they cut off congruent segments on every transversal. So that means that since these are parallel, since these 3 lines are parallel to each other, any transversal cuts through, they're going to be congruent to each other. That means that EF is congruent to FG, which is congruent to GH. So, if I want to know the length of EH, I'm going to do 2.25 times 3. I'm going to add it 3 times, which equals 6.75. So, try to got it down here.